Hello and welcome back to my channel. Today I'm going to be giving you a crash course on separable equations and initial value problems. So when we are given separable equations, they look a little something like this. They have a y value over on the other side. And our goal is to get our y with our dy and our x with our dx, and then we can integrate on either side. So for example, for this problem, we multiply by y squared and we multiply by dx to get y squared dy is equal to x squared dx. And then we can integrate either side. And then we can integrate to get 1/3 y cubed equals 1/3 x cubed plus c. And we only need to add plus c on one side because it's a constant and there's only going to be one of them. Our next goal is to get y by itself, as in just y equals some function. So we can multiply by 3. Remember, this is an arbitrary number, so if we multiply it by 3, it's also going to be another arbitrary number. So we can leave it as c. And we can take the cube root, and we have our solution. Y equals the cube root of x cubed plus c. So initial value problems are when we are given this bit right here, plus an initial value, some y of x equal to some constant d. Let's say for this problem, we are given y0 is equal to 2. So for this, we're going to go through all the steps that we just did to get y by itself. The point of the initial value problems is so that we can solve for our c. So now that we have that y of 0 is equal to 2, we can plug in 0 for our x and 2 for our y. So that means that 2 is equal to the cube root of 0 cubed, which is 0, of c plus c. So we can take the cube of either side to get 8 is equal to c. And now that we have this value, we can write out our final equation, saying that y is equal to the cube root of x cubed plus 8. And that is our final solution, and we're done. Thank you so much for watching. This has actually been part of my final project for my math degree. If you have any questions, I'd be more than happy to answer them in the comments below. Once again, thank you so much for watching and have a great day.